To me that they can see my screen and hear me.
Yes, I
Great,
can
great,
see
great,
the
great,
screen.
great, great. Right. We'll get going eventually. Right. I want to continue on with containerization today and indeed next week and probably the week after as well. So I'm continuing on with these slides here. Sorry, I've added these over the weekend, but I don't think we'll get to them really. So we're continuing on with these slides here. I do have a new lab for this week. There's the lab showing up there? Yeah, you can see on the extreme right, there's a new lab. Uh, we'll see how far we get today as to whether we'll get onto that lab or not. Now, as usual, there are things popping up in front of my screen that I need to get rid of. Okay, I'm just going to bring up my slides. So the topic is containerization. And containerization is a technology for packaging and deploying applications in a way that we can be guaranteed that the application will run successfully, irrespective of the underlying platform. By platform, we mean hardware and operating system, which may seem like a straightforward thing, but it wasn't for many decades, really, I guess. And if we go back to, you might remember this image from last week, where we're at in this uh, agile stroke DevOps process is ultimately we're dealing with this area here, even though we won't deal with deployment until a number of weeks down the line. And arguably, we're talking about building applications as well, although we won't see that either until perhaps next week. This is the technology that we're going to be using, this Docker technology. So is as a way, as I said, it's a way of packaging and deploying your application um, to simplify that whole process and make it consistent and reliable. From a technology stack point of view, when we talk about containerization, this is how we view it. So we've got our underlying hardware, be it your own laptop, be it some sort of sophisticated server, or even in the cloud. On top of that, we've got a some sort of some operating system, your host operating system. Then we've got what's called a container engine. So we do need to have the container engine installed on the particular hardware. And then each of these things here is a single container which is running an application. Okay. And what we're also guaranteed by this containerization idea is that these two applications are completely isolated from one another. And that's really important if they're actually running in the cloud. You know, if you're running your application, you want to make sure that there aren't other applications running in the cloud that could potentially get at yours. And we'll see a little bit later on how that isolation is achieved. The nice thing too about containers is that a container, so as I said, each of these here now is a container. These containers are very quick to get up and running. Um, so what tends to happen, is if a container crashes, then we just delete it and recreate it, and can happen in a matter of milliseconds. What preceded containerization was something called virtualization. Virtualization was this idea here. Okay, it was a really useful technique at the time, but you remember that the idea of virtualization is okay. You've got your underlying hardware. You've got your host operating system. All right. You've got your host operating system. Then you need a special piece of software called a hypervisor. And on top of that, then uh, you can spin up or start up individual VMs where each VM is running its own full operating system. And then on top of that is where you put your application. So virtualization is much more what we say heavyweight than containerization. Also, if for whatever reason this virtual machine crashes, then okay, we can automate the restarting of it, but it's going to take much longer to restart it than it would to restart a container. So speed is one of the advantages of containerization over virtualization, amongst other things. And so the containerization technology that we're going to look at, and by far and away the most popular and the original, arguably, is the Docker uh, framework, I guess we'll call it. Yeah. So going to move on to uh, here. Just before I move off of where do I want to get to? I want to get to here, yeah. When we're talking about containerization, there are two key uh, terms that we use, images and containers. An image is a static thing. An image is what we create at build time. Now, we won't get to build our own images until perhaps next week, or maybe the week after. So we will build images ourselves using Docker, the Docker tool itself. So an image is a build time construct. Okay. A container then is a runtime construct. And so what a container does is it executes an image within it. Now, in most cases, a container is only running one image. You can have containers running more than one, but we won't ever get to that stage. And an image has the entire file system that it needs, and all of the other uh, uh, artifacts that it needs in order to run. So that would obviously it has its the application code uh, itself. It has any third-party dependencies contained within it. It has any operating system tools and libraries contained within it. Any configuration files, they're all packaged inside the image. So it doesn't depend on anything external. And that's why containers can be completely isolated from one another. They don't depend on anything from the underlying operating system, other than the operating system being able to create an operating system process, which is a runtime thing. A container then is a single running instance of an image. And you can have more than one container running the exact same image on the exact same piece of hardware. There's no problem with that. They're still completely isolated from one another, though. So Docker, anyway, is the containerization technology that we'll be looking at for the next couple of weeks. And you started looking at it already. And this is the architecture of Docker. I know I'm going back over stuff we did last week now, but so be it. Um, the main thing, I guess, is this Docker daemon, okay, which is it's responsible for managing all of your containers that are running on your local operating system. We will be using Docker on our local uh, laptops. And then later on, we will run Docker in the cloud in an EC2 instance, but that's a bit away. So when you're running Docker locally, when you start up the Docker tool locally, what you're actually starting up is the Docker daemon. And then you also have a command line interface and a GUI interface. So over here on the left is your kind of client, which could either be, as I say, the command line version of it or the GUI version of it. I think it's useful to get reasonably familiar with the command line option because you may not always have the GUI version available to you. So the client in whatever form, when you type commands at the command line, you're talking to the Docker daemon. And typically what you're doing is you're asking it to build an image or to run an image inside a container. And so over here, what we're showing is that your daemon that's running on your local machine, it's essentially managing any containers and images that it has locally. If you want to, if you build an image of an application that you have developed and you want to share that application with other people, then what you do is you publish the image onto a registry. There is a registry that comes with the Docker framework called Docker Hub, but there are other registries as well. Okay, so this is your typical workflow. We won't get to do step one until, as I say, maybe next week or the week after. But once you have an image, uh, you can then create a container of that image. That container, remember, is the runtime thing. You can push the image up to the registry so that other people can do it. Other people can pull the image down onto their local machine and then presumably create a container instance of it. And these are some of the commands that did you do any of them? He did Docker pull, Docker run in the lab the last day. But I'm conscious of the fact that in the lab the last day, ideally what I wanted to do is do a quick demonstration in the lecture and then let you work on the lab. And so you'd have some familiarity with what you were doing. But because of other things that got in the way, I didn't get around to doing that. So let's supposing, so I've started up the Docker daemon on my machine here now. And what I've got on this slide and on the next number of slides are some of the most common commands that you will use from the command line in order to interact with with the Docker daemon. So take this command here, right? What this command does, I'm specifying down here, right? It does a number of things. It actually, the very first thing it does is it tries to find this image. This is an image name, okay? And because I haven't told it where the image is, then by default, it assumes that this image is stored up in the Docker Hub registry. So if I just actually run this command now from the command line myself here, and maybe just before I do that, if I show you my Docker, see where are we? Try it this way. Trying to get used to this new machine that I have. Okay, here we are. Now, what I'm showing you here is the GUI client for that comes with the Docker desktop. And if I click on here, it's showing me all of the containers that are currently running, which there are none. If I click on this, it's showing me all of the images that I currently have stored locally on my machine, of which there are none as well. So if I now go back to just from the command line, and I don't know. So I'm just inside my VS Code, and if I go Docker pull, sorry, run, Uh, Now, what it's going to do is it's going to connect up to the Docker Hub registry, look for an image called HTTPD, which is an image that contains the Apache web server. In the lab last week, he used Nginx, which is just another web server, okay, running packages as an image. And if it finds that, and if I now just flick over to my browser, and here's the Docker Hub uh, browser client, and if I do a search here for the image HTTPD, you can see it's finding a match. And if I click on that, so this is the documentation on the HTTP D image, okay, which we'll come back to. So it is up there. And if I hit return on my command here, it's going to download the image locally and then run it. Now it downloads it in layers, which we can just ignore for now anyway. An image is more than just a single file. It's actually a collection of files that are linked to one another in layers. So it's downloading all the layers, and then it starts to run it. Sorry, it creates a container, and it gets that container to run the HTTPD image inside it. And it's running it in foreground mode. So the reason it's hanging here now is because it has taken over my command line. It's running in foreground as opposed to background mode. But if I switch over to my Docker GUI, and if I look at the images, I can see here's the HTTP image. So it has stored it locally. And if I look at my containers, there is a container running, and it's given it a kind of a generated name. It's better when that you give it a specific name that you recognize, but if you don't, then it just generates a name for it. It's currently running, so that means the image is running successfully. It booted up successfully. It may not always be the case when you create your own images. And other than that, we can't do anything really with the web server. For now, anyway, we can't connect to. We know that there is a web server running inside this image, the Apache web server. But ideally, we'd like to be able to connect to that web server from a browser tab. But right now, we can't do that. Uh, we'll see how we can do it in a while. But for now, we're happy, right? The image is running, and that's great. So back to my slides. Slides. That's Docker run. That's the kind of 101. Um, that's fine. If you run the Docker pull command followed by the name of an image, that just downloads the image. It doesn't bother running it. And sometimes that's what you want to do. And we can look at that in a minute. If you want to upload an image, it's Docker push. We won't be doing that for a while because we need to be able to create our own images. The image name part here, so in the example that I showed you there, the image name was just HTTPD, and it knew that that image, because you didn't tell it where the image is, it assumed it was up in Docker Hub and it found it. But the full version of an image name is what I'm giving you here. You first of all have to specify the registry that the image is stored in. You then have to tell us, well, which account, if you like, within the registry, because there are lots of people will have accounts on the registry, you will create a Docker Hub account. I have a Docker Hub account. So you need to tell it which account up on the registry is the image located in. And then you tell it the image name. And finally, you tell it which tag associated with that image are you interested in. Think of tag really as kind of a version number for the image or some way of distinguishing one version of the image from another because there may be multiple versions of an image available up in Docker Hub. And in fact, if I go back to here and I look at my images, you can see this is the image name and you can see the tag here is latest. So it by default it picks the most recent or latest version of the image, which may not always be the best thing to do, but just go back from that, sorry. So I did not specify a registry. I did not specify a, sorry, I did not specify a user. I did specify a name, and I didn't specify a tag when I used the docker run command there. So it defaulted for all of those parts. Now, the default registry is Docker Hub. This is the full name for Docker Hub. Uh, the default user is library. So if library really means public, any public, officially public images that are available in the registry. By public, we mean available to everybody. The default tag is latest. So if we take those three defaults, then this here now is an example of the fully qualified name for a, in our case, the HTTPD image. So I could just as well have used that full qualified name rather than just HTTPD. And if I do that, now just for my own convenience, I've got it here ready to cut and paste. So if I just grab that, I'm just doing Docker pull this time rather than Docker run. I could do Docker run. I'll open up a new, in fact, what I'll do is I'll just kill this process. And having done that now, just before if I go back to my GUI and look at containers, you can see that the container now is exited or um, no longer running, I guess. Yeah, which makes sense. Back to here. And I want to do this. Okay. And if I now go back to here and look at my images, I now have two images, but because I use different names, even though we know that this image and this image are actually the exact same, uh, it stores them as separate entries in my list of local images. Although, if I go back to here, right, it was clever enough actually to work out that it didn't have to download the entire image again. Uh, I don't need to get into how it actually knows that, but it does anyway. You can see here there was a lot more involved when I ran the docker run command with HTTPD. It downloaded the entire image, the various, what we call the various layers of the image, and then it ran it. Whereas when I did the docker pull command here, doesn't seem to have downloaded anything new. That's because it realized that it already has all of the layers. But it does put a new entry. Uh, Now I'm using the GUI client there a lot, but if I was just to go, oh, what has it done? Sorry, that was by accident. If I do Docker, let me spell it, Docker. Yeah, that's consistent with what we see on the GUI side. Now, unfortunately, though, if I want to run a container for this image here, I do have to give it the full name, which is quite long-winded. So, like, if I want to actually run it, so here's the command actually. Uh, Sorry, now I'm going to make it one line. And I'm adding on two other options as well, just for convenience, really. The -D option means you want to run the container in background mode, so it doesn't uh, occupy my shell. And the minus name option is where I can control the name for the new container rather than letting Docker auto generate a name. So if I grab that full command and go back and look at, are there any containers now running? And you can see there is a container running. This is the name for the container, which is what I asked it to be. Seems to be sensitive to the name. And other than that, can we tell? Let's see. Yeah, okay, that's okay for now. Yeah, here we can tell what image it's running. And we just ran out of space really, but we can see that the image is the fully qualified name that I gave it. Yeah. So that's Docker run and Docker pull. And we now know that, for example, when you were using Nginx the last day, it was pulling the image from Docker Hub. If I go into my browser again and I go back to here, and if I type Nginx, you can see here it's finding it. And there are a couple of them. This is the one I want actually. And this is the image that you were working with the last day. So that's fine. So that's the image name, the fully qualified version of the name. If you want to list your images, as I say, Docker images, if I do that, it's pretty simple though. But if I do that from the command line, although as you can see there, using the GUI is obviously more convenient just for looking at what images and containers that you have. But if you don't have the GUI available to you, Docker images. Okay, and it looks, that's right. I have that image and I've got the fully qualified version of the image as well. Tagging an image. So the tag there that we've been using implicitly as well as explicitly was latest, but typically the tag refers to um, going to correct myself. Tagging means giving an image an alternative name. And again, it's something that we will be using uh, a little bit later on. But for now, this command here is the command that you use if you want to give a current image another name. Yeah. So where we might actually use that, even though this is not the typical use case, is if we go back to we go back to here, and if I look at my images, now I know we downloaded these images from Docker Hub, but typically tagging is something that you do with your own images, but we can demonstrate it here as well. So I've got this second image here, and it's got a very long name to it. Supposing I want to give it a much shorter name. So let's do that using the Docker tag command. And again, I think I have it here ready just for convenience. Or do I? Let's see. There we go. So I'm doing Docker tag. I'm telling it to take this current image and create an alternative name for it called this. And I've decided that the version number or the tag will be just 1.0. Yeah. So if I grab that command and run it. Okay, and it's run it. And if I now look at my images, my local images, you can see uh, here's here's the new one here. Okay, with my name and its tag or kind of version, I've just arbitrarily decided as 1.0. Sorry, that keeps, this is very sensitive though. Yeah. And now I could run a container for this particular image, even though it's the exact same as the other two. So maybe if I do that, my HTTPD, and I'll just recall this one here. Now I want to run, I'll call it my server 2. You always have to give it the tag number. And again, if I go back to here, look at my containers. Here's the my server 2 container, and here's the image that it's running, and it seems to be running successfully. So far, so good. Still, though, we can't really do anything with those containers. So tagging is giving an image an alternative name. You can delete images. That's fairly straightforward. Although, to be honest, you know, I tend to do it from the GUI rather than from the command line. Kind of. So if I just, for example, take which one will we get rid of? We'll get rid of, sorry, images. Let's get rid of this one. Starting start a new container. That's okay. Docker run. We've done that lots of times. Now, the Docker run command, though, it has many command line options, some of which we've seen just now, and some of which you've used in the lab the last day. These are the most common options. So the minus minus name option is where you actually control the name given to the container rather than the auto-generated name by uh, the Docker daemon itself. The minus D option is when you want to run the container in background mode, which you would want really in the vast majority of cases. The minus P option is interesting. That allows you, if the application running inside the container is using a particular HTTP port. Now, it may be listening on a port, and that would certainly be the case with our Apache web server. It is listening on port 80, as far as I know, but that port is only accessible within uh, kind of within the container. It's not accessible outside of the container. So what the minus P option allows us to do is to link a HTTP port associated with the host machine, my laptop, link that with the port that the image inside the container is listening on. And so we'll do that in a moment. The minus E option is perhaps the image needs certain environment variables to be set. And the minus E option allows us to do that. We'll see a lot of that being used in this week's lab. We didn't use it last week. The minus V option, you actually did get a chance to use in the lab as well, but I'll come on to that in a second. And then there are some other ones as well, which can be useful as well. For example, this one here, the minus minus RM option, that will always just delete a container once it has exited. And so, for example, if I had used the minus minus RM option when I started the very first container, then, and you might remember, I ran that container in foreground mode, and then I hit Control C, and that essentially uh, caused the container to exit, but the container is still there. If I go back to here and I look at my containers, you see this one here? The container is still there, but it's in exited status. Now, qu quite often when a container goes into exited status, you just want the container to be deleted automatically. Not always, but very often that is the case. And so if I use the minus minus RM option when I ran that container, then it would have actually been deleted automatically when I hit Control C from the command line. So the minus P option there is going to be very useful to us. So it allows us to publish. So for example, if we want to publish port 80 from the container as port 8080 on the host, then this is how you would use the minus P option. Minus P, I think they should actually be the other way around. Did I make that mistake? Let's just do it to see which way. That was pretty silly now for me to put them the wrong way around. But anyway, if we go back to, in fact, what I'll do is let's do a complete cleanup of my containers. Let's just get rid of all of them. And let's start up a new container. And let's use here. So we want to run let's just run the HTTPD image. Sorry, let's just go back again, sorry. Back to my images. Okay, we've got my HTTP, so I'll use that. So this command here, I want to run. the my HTTPD image version 1.0, which I have locally. I want to give the container that name. That's fine. And here's where I'm telling it to link port 80 within the container, link that to port 3000 on my desktop machine. I hope now I've got that the right way around, but if I don't. So, and I'm running it in background mode. Yeah, good. So here's my container, and sorry, here's my container. And you can see actually there's some extra information here related to ports, and it's telling me that port 80 is mapped to port 3000. And what's nice about the GUI is that this is actually hyperlinked. So if I just click on the hyperlink, hmm, did I get that the wrong way around? Oh no, let's see. I think I might have got those ports the wrong way around, but let's try 3000 anyway. Okay, so the it works is actually coming from the Apache web server that's running inside my container. Okay, even though the web server is listing on port 80 within the container, because I linked that port 80 to port 3000 on my desktop, I can now connect to it externally, if you like. And that's something you will be doing a lot of, obviously. So that's the minus P. We'll talk a little bit more about the P. Well, obviously stands for port, but the technique that we're using there is called port forwarding, in that we're forwarding any request. So essentially, my browser is sending a request. Localhost is my desktop machine. So I'm sending a request to port 3000 on my desktop machine. And what happens then is Docker will forward that request onto port 80 of my container. And because my Apache web server, which is running inside the container, because that's listening on port 80, it receives that request and it responds to it. And the response is it sends back this simple web page uh, that you see on the screen. I can pause for questions, but I'm not sure if people have any question about that. The other really, hmm, okay, as usual, I've run out of time now. My start of the lecture was a little bit all over the place because of technology reasons. So again, what I'm going to do tomorrow is I want to get through just a couple of more of these slides, and uh, then I will let you work on this week's lab. Now, I just want to finish off one or two slides, and then I'll let you work on this week's lab. So roughly where we finished off yesterday was here. So we were able to start a container specifying an image, and if the image, to date now, the only images we can run in containers are those that are kind of publicly available from Docker Hub or other registries if we knew about other registries, which we will find out about a little bit later on, but we'll mainly use Docker Hub. And if we want to run a container, specifying an image, if the image is not locally available on our desktop machine, then it will download the image. It actually downloads it as a series of what are called layers. You could think of layers as individual files that make up an image. and then it starts off the container uh, for us. Now, typically, though, we might want to interact with the container ourselves, and so that's provided the image that's being executed inside the container wants to be communicated with, and if it does, then what it will do is it will make a port, a TCP port that it listens on. The problem, though, is that we cannot use that port ourselves externally. So, for example, if we're running a web server, and typically web servers might be listening on port 80, we cannot send a request from a browser to, let's say, localhost port 80, because localhost port 80 is referring to port 80 on our desktop machine. It's not going to access port 80 within the container. And so for that scenario, let's see, where are we? Here. Here. So the Docker run command provides this -p option, P for port, I guess, or publish. And the way we use it is like this. I'll just get my pen. Um, we specify essentially two ports to the -p option. The first port is the port that you want to use on your host machine. The second port is the port that's being used by the image within the container itself. And so for this particular example, we're saying whenever we send a request to port 8080 on the host machine, then map that or forward that onto port 80 within your container. And so that's roughly where I left it off yesterday. So if I get back to where I was yesterday, now in my case, I'm using the HTTPD image, this one here, which is just a web server image, similar to Nginx, which is what you were using in the lab. So at the moment, I don't think I have any containers running. No. So let's start up an image, and I know, well, how do I know? Well, if I go to Docker Hub and I look up this particular image, then in the overview part, you'll get some information on it, including what is the image at all and how do I use it, I think down here. And so if I scroll on, it's giving me, let's see, it's telling me here, how to actually run it. So it's telling me that, look, it's port 80 is the port that the container or that the image uses, or the application inside the image. Now, you can use any host port that you want to. So let's maybe if I just copy that. Now, there's some other stuff being done here, which I will ignore for now. Go back to my VS Code. Just going to open a new file for myself. So let's see now. Yeah, I'm going to leave out this part here. And I'm actually using the latest version of HTTPD rather than that version. So how do I know I'm using the latest version? Well, if I go back to my GUI, and look at the images, HTTPD, and the tag is essentially kind of the version. The tag is latest, so that's why. And so the command line options here are the -D is for run the container in background mode. The minus the IT is to have an interactive, make the container interactive, which we can just kind of ignore for now. The name is the name I want to give the container. Here's my port mapping. I'll stick with port 8080, although I can use any port. And the rest, if I grab all of that, check to see, let's do it from the command line. If I go do Docker, yes is to list my running containers. That looks like it's running successfully. And what it now means is that if I go to my GUI, and I'll just use this convenient hyperlink here, but if I click on this, then you can see that the URL in my browser is localhost port 8080, but that's forwarded on to the containers port 80, and this is what the web server is returning back to me. Just pause for a second in case anybody has a question about that. I know you've done it in the lab, so you probably rationalized it now in your minds, but just in case. No. Back to my slides. I'm just going to skip on to, okay, these are just some more commands. Docker PS is to list all of your running containers, but a container may be in exited mode or kind of stopped mode or paused mode. So if you want to see those containers as well, you've got to use the -A option. Doesn't arise right now with us. Stopping a container, stopping it does not mean deleting it. It just means kind of pausing it, which you may want to do sometimes. To restart it, it's the docker start command followed by the container name. Removing a container, they're all fairly straightforward. Now, admittedly, all of these here you can do from the command line, but you can do that from inside the GUI as well. Although I know I have said to you a number of times, get used to using the commands because you may find yourself in a scenario where you don't have the GUI available to you, in which case you're kind of cornered. But if I look at my containers, over here is where I can manipulate the container in various ways. The exec command is a really useful command when you're debugging a container or debugging an image that's running inside a container. And so if we use this command here with our container that we've just created, so this is typically how we would use it. Well, sorry, this is the generic. Let's see. Yeah, sorry, this is the generic form. Docker exec, the name of the container, and then whatever command here is the command that you want to run inside the container. Now, I'm not sure, did I say to you that containers are always essentially Linux-based containers? Okay, so the commands would be valid Linux commands. So like ls or any of the common Linux commands. However, if you specify this as the command, essentially what you are doing is opening up a terminal session within your container. And again, I know you've done that in the lab, but let's just do it with the container that I have at the moment. So if I go Docker exec and -IT to make it interactive, my container name, let's see, can I grab it from up here? I'm assuming people know that Bash is one of the different types of shells that you can associate with Linux, um, a Linux system. The other ones being SH or CSH. There's also a ZSH um, command line prompt. So if I hit return, now I'm inside the container. Yeah. And so if I do ls, it's showing me all of the files in the current folder or the current directory that I'm in the container. How do I know what directory I'm in? Okay, so that this directory here now is, again, it's a directory inside the container. And I can CD to any other directory that is available to me within the container. I'm essentially kind of inside now a Linux system within my container. Now for the Apache web server, when we did this, where did the it works come from? There must be a HTML file within the Apache web server that contains this text. How do I find that file? Now, if I go back to Docker Hub, and really, I guess you'd need to read the documentation, but I can actually glean it from, let's say here, it's user local. Yeah, since I copied that, it's, did I delete it? I deleted it, sorry. I'll just copy this again. I know I'm taking some kind of jumps here now in this, but I happen to know that this path here is the path where it stores its default kind of website. So it's user local Apache 2/HTML docs. Now going down to my terminal, and when I go pwd, I'm currently in the Apache 2. So if I do cd HTML docs, cd. Am I reading that correctly? HT docs, sorry, is it HT docs, all right. And there is a file there called index.html. And if I just run the cat command on index.html, then lo and behold, that's what we are. Are we reading that right? Yeah, that's what we got on the browser. So that seems to add up. Now that's just specific to the Apache web server. For the Nginx web server, it stores its default index.html somewhere else, and you just have to read the documentation on Nginx to find where exactly does it store it. Now, if I go back to my slides, the other interesting option with the docker run command is the -v command, and that essentially allows you to bind or link or mount a directory on the host machine on your laptop, link it to a directory within the container. So what we could do for our HTTPD container is if we could point it at a folder on our desktop which contains an index.html or indeed an entire website, and link that with the directory that I was manipulating just there now this moment within my container, then I could get my container to serve my website that's currently exists on my desktop, serve that, get the container to actually serve that from HTTP requests. So I've got, if I look inside here, I've got a folder called website, and there is an index.html there. Okay. It's similar to the one that you would have used in the lab, actually. So that's the index.html page. Now I want my Apache web server running inside the container to actually serve this file rather than the file that's contained within the container itself. And so to do that, I need to use that -v option. V kind of stands for volume, to link this web page here with the directory inside the container that contains the index.html. And if I go back to the command that I copied from Docker Hub, it's the -v option, and the rest then, what you specify here is the path name within your host machine that contains the files that you want to have bound to the container, followed by the path name within the container that you want them bound to. So yet again, if what I'm going to do is I'll actually leave the container running. I'm going to start a second container. First of all, I'm going to exit out of this one. And if I start a second container, now I cannot run the second container. Well, it wouldn't make sense to run the second container off port 8080, so I'll do 8081. I also need to give it a different name. Oops, I didn't want to do that. Sorry. Kill that container. The one I want to kill. Now I need to replace this with where my website is. So in my case, I think it's dot slash. So this part here is just I'm using a relative path name, and I know the website folder, this one here is just one level below where I currently am on the command line. And I want to use a different port as well. And I need to give it a different name. I think that's everything. So I should have two containers running now. Yeah, one is running, is accessible from port 8080. The other one is accessible from port 8081. And if I click on this one, then this is the website that I have on my host machine. Yeah. And if I made changes to this website, essentially, if I go in here and make a change to it, let's go page, save that, go back to my browser. I need to do a manual refresh. Yeah. Now the other Apache server is still running. This one here. That's a completely separate container, and it doesn't have any volume binding or volume mounting. So if I keep, if I'm refreshing that, it's still showing the old page. Right. So that's running containers. It's also, we've demonstrated what's called port forwarding or port mapping. And I've shown you how you can associate a file or folder, typically a folder on your desktop machine, how you can bind that to a folder within the container, which is something you would do maybe at development time. You would do it at runtime as well. Um, okay, let's move on. I'll pause just for any questions. I don't know if you are in the habit of asking questions at lectures, but I'll give you an opportunity anyway. Check to see if there's anything in the comments. No, okay. Back to my slides. So I've talked about the exec Docker logs is is certainly useful when you're debugging, because any console log statements that the application running inside the container, those console log statements, when you're debugging, you'd want to be able to see those. And so the Docker logs command will show them to you. Docker inspect can be very useful as well. You can inspect lots of different things in Docker, one of which is containers, uh, and that may be useful during debugging. Now, I just want to just start off this set of slides on Docker networking. So if I go back to the website now, so this set of slides here covers more Docker stuff. Is that loading? Why didn't that load? That doesn't look good. I need to fix that. There should be a set of slides behind that link. And the set of slides is just more Docker stuff, really. Uh, there are two aspects of Docker that I need to talk about, not today now. I'm just going to start this one and then I'll let you work on the labs. But it's Docker networking. Networking is a really big and important part of the Docker platform. And what networking allows you to do is to uh, isolate containers from one another. So the first point I'm making on this slide is that really when you're talking about deploying Docker applications, you're not just deploying one container. Typically, you're deploying a set of containers, which collectively represents an entire application. For example, if you have an application that's using a database, you would have one container which just hosts, one container which just encapsulates the database, another container which would contain some of the maybe part or all of your application, or you might even break your application up into separate images. And so you'd have a number of images which contain the functionality associated with your application. So you're going to have multiple containers which collectively represents your overall application. Now, those containers will need to communicate with one another. And the way we do that in a Docker environment is we leverage Docker's networking capabilities, virtual networking capabilities that's just built into the the tool itself. And you'll actually be doing that in a small scale in this week's lab. So I'm saying the power of Docker is realized when you compose your application out of multiple containers. And there are two aspects to Docker that enable that: Docker networking, which is I've just been talking about there, and which is a small part of this week's lab. It'll be a bigger part of next week's lab. There's also something called Docker Compose, which is a way of describing your overall application. So our overall application now is comprised of multiple containers, and we need to somehow be able to describe that architecture um, in a codified way. And Docker Compose allows us to do that. We will use Docker Compose further down the line in a lab in a couple of weeks' time. So I'm going to ignore Docker Compose for now. Now, when you start up your Docker daemon locally or anywhere that you run the Docker daemon, as part of its startup, it creates a virtual network. In fact, it creates three virtual networks. And from the command line, if you just type the command docker network ls, yeah, we can see that there are three quote unquote networks that are kind of the default networks that are created by Docker. But you can add on other networks to that list, and you will be doing that in this week's lab. Now, so there's three networks. They each have an ID. That's okay. They each have a name. Now, these are the default ones, but the names that you give to your give to your networks are completely arbitrary. The driver part is important. The driver, when we talk about the driver associated with a network, just think of the type, what type of network it is. And I think there are about 7 different types of networks. The only one that we will be concerned with is the bridge type network. Now, it's unfortunate that one of the default networks that's created is called bridge and its type is bridge. That I'm not sure. I would have preferred if the Docker people gave the default bridge network a different name, because when people are talking about the bridge network, are they talking about the default bridge network or another bridge network? Anyway, we'll have to live with it. So there are these 3 types of networks. Now, I'll talk about networking in a little bit more depth next week, but um, if what we can do is we can inspect these networks. And for a bridge network, i.e. a network of type bridge, what Docker does is it allocates an IP subnet range to that virtual network. Any container that we create by default is added to the default bridge network. And each container, it gets its own IP address within the IP subnet range that has been allocated to the default bridge network. Now, how do I find what is the subnet range associated with the default bridge network? Well, the docker inspect command actually does that for me. So if I go Docker, the Docker inspect command I mentioned there a few moments ago, you can use it for different types of artifacts within the Docker platform. You can use it to inspect a container, and you can also use it to inspect a network. So in the case of networks, what you tell it is, what is the name of the network that you want to inspect? And we want to inspect this one here. So bridge. Now there's a lot of information returned back to you, most of which we're not going to delve into, but there's one part that I want to pick out, which is this part here. And that's telling us the subnet IP address range that Docker has dynamically allocated to this network. A bridge network also has a gateway assigned to it, a virtual gateway, which means that any container within the bridge network can actually make HTTP requests within it, and it will reach the outside world, if you like, the internet, because there is a virtual gateway associated with every bridge network, including the default bridge network. So if we just focus on this for a second, so this is the IP address range that Docker has dynamically allocated to the default bridge network. That means that each container that's running inside this network will have an IP address within that range. Now, at the moment, I've got let's go back to here. I've got 2 containers running. Yeah. And when I ran these containers, I didn't tell Docker which network it should assign the containers to. And by default, it assigns them to, you've guessed it, the default bridge network. So these 2 containers do actually have an IP address assigned to each of them. And those IP addresses are going to be within the subnet range of the default bridge network. Can we prove that? So the IP is 172, that's 17.0.0/10. If I inspect one of those think I can actually give it the container ID or the container name. I think both will work. Let's see whether this works. Again, loads of information sent back to us, but right now we're just interested in this part. And here is the IP address assigned to the container. And indeed, looks like it's an IP address within the subnet range assigned to the default bridge network. So this container has its own unique IP. Now, of course, this IP address is only accessible within the bridge network. You cannot use this IP address outside and expect to be able to contact the this particular container. We know this container is running one of the Apache web servers. You won't be able to attach you won't be able to uh, um, communicate with that Apache web server just using this IP address because it's only valid within the virtual network, the default bridge network within Docker. But the fact that it has an IP address means that other containers inside the default bridge network could use this IP address potentially to communicate with it. And you'll actually see that in this week's lab and in next week's lab. Networking is not we're using networking in this week's lab, but we're not looking at the kind of low level detail. We'll do that in next week's lab. So the overall point that I just want to make for now is Docker uses networking extensively to facilitate the idea of isolation, container isolation. And by default, there are 3 networks created. The most important of those 3 for now is the network whose name is bridge. Though each network has a type, the only type that we will be looking at are bridge type networks. A bridge network is one that has a subnet IP address range allocated to it. It also has a virtual network bridge associated with it, not a physical one, a virtual one. And that bridge, that virtual bridge device allows containers within the network to communicate with one another because the bridge actually performs routing. It also performs DNS resolution, domain name resolution, which we'll cover in next week's lecture. And thirdly, the bridge allows containers within the network to access, it gives it a gateway to the outside world, so to speak, so it can access the internet externally. Now, if I go back to the website and if I this lab here, which is this week's lab, this is what we're going to be doing, okay? We're going to have an application that is comprised of 3 parts. There is a database, which is running as a container. There is what I'm calling a web-based admin tool, which is also running inside a container. And we're downloading these images from Docker Hub. Both of these are running inside the default bridge network. So they have IP addresses and they communicate with one another. And they need to because the admin application allows us to essentially administer the database, see what tables are in there, etc. And thirdly, we have a standard Node.js application, and I'm providing you with all the code for that, which you download from GitHub. Now for now, this application, we're just going to start it from the command line. It's not, as we say, it's not Dockerized, not running within a container. So it's external from Docker. But it does need to communicate with the database because this application is going to be writing uh, or reading from the database. So there will need to be some port forwarding going on here in order to allow it to do that, because the database is listing on a particular port, but that port, as we know now, is only meaningful within the context of, if you like, this box here, which is the Docker daemon box. And so this is the architecture, but we're actually going to create two running applications that follow this architecture. If I just go forward, there's a demo app 1 and there's a demo app 2. They both have the exact same architecture. Demo app 1 is using the MongoDB database, and demo app 2 is using the Postgres database. You don't really need to know about the internals of those databases, although I know you will be covering MongoDB in the web app dev module, but you don't need to worry about the internal workings of MongoDB or Postgres. Postgres is just a standard relational database. So I'm going to let you work your way through this lab. So it's mainly about kind of setting things up and running containers and hooking them up to one another. And let's just see how you get on. And you can contact me via Slack. I'll be available online for the next, what time is it now? 10:16, for the next 2 hours. Again, I'll give you an opportunity to ask any questions if there are any questions. No? Okay, so see how far you can get with the lab, and do contact me if you are having any problems. Okay, we'll leave it at that for now.